Good afternoon. I'm Brian Bartholomews. I'm at the Tomcat Center for Sustainable Energy, and I manage the Innovation Transfer Program that we run in that center. So I'm sort of the warm-up act for the stars of the show, who are the entrepreneurs sitting along the wall over there. And you're going to hear from them about 11 different enterprises that they've started, all of them with very different and fairly interesting energy components built into their business models and their products and services. They're also at various stages of their development. Some of them are very early stage companies, just kind of getting off the ground, perhaps not far removed from some of the classes like the one Stuart talked about. Others are much more at a much more advanced commercial stage where they have products and customers and all the rest of it. Now, some of the technologies and solutions might sound familiar to those of you who have participated in past GSEP symposia, because perhaps they were sort of directly or tangentially related to research presentations like the ones you've heard, or even the poster sessions. Before we jump into the presentations themselves, I wanted to leave you with a couple of thoughts. They are joining extremely large ecosystem of something like 18,000 companies in California that have been spun out of Stanford. 18,000 companies that have cumulative annual revenues of over $1 trillion and employ more than 3 million people. So they're in worthy company, and those are numbers certainly to reflect on and to perhaps retain. What we plan to do is have the companies come up in alphabetical order and tell you about who they are, what their company does, what their products and services are, who their customers and markets are. And what I'm hoping is that they get you all fired up and wanting to rush down the hall and meet with them and learn a little bit more about what they're doing and what their journeys have been so far. So without further ado, I'll have them come up on stage one by one, introduce themselves. They have a short period of time available to them, so we'll cut down on redundancy. So first, let's have Chris Hopper from Aurora Solar come up here and tell us how they're revolutionizing the design and evaluation of solar installations. And then we'll just cycle through them very quickly. It's going to be a rocket ship ride, and then it's down the hall. Thank you.
Hi. We start with A, so I get to go first. But let me kick it off with a question. Did you know that out of the total cost of a residential solar installation, the equipment, the hardware, only constitutes around 40%? So if you were to go solar today, you'd spend around $20,000 or so, but only $8,000 would be the equipment, so the solar panels and the electrical components. $12,000 would go towards soft cost. What are soft costs? It's obviously installation labor, it's permitting cost, customer acquisition cost, financing cost, design cost, and site visits. So that's a pretty astounding kind of chunk of the total cost, 60%. When I look at the number, for me, there's one thing that strikes me, and that's, if we were more efficient at getting solar onto your roof today, we could effectively cut the cost in solar in half. So that's a tremendous potential for improvement, and that's without any need of any further technological breakthroughs or improvements. My name's Chris Hopper. I'm a co-founder of Aurora Solar, and we're strong believers that software can help in that, in making solar power more affordable, and software is actually necessary to enable distributed solar at scale. We are a 35-person company now. We were founded in 2013 with help from the Tomcat Center, so thank you to Brian and team, as well as support from the DOE's Sunshot Initiative. We've now grown into a 35-person company based in downtown Palo Alto, and we've become now, in a couple of years, the leading sales and design platform for solar companies. We have clients all over the US and internationally, small and large, and those clients are now using our platform to design more than 50,000 solar installations per month. And soon we're going to be celebrating a big milestone with 1 million systems designed in our software. So we're looking forward to that day. If you'd like to learn more about what we do, please come see us at the showcase after the presentations. Thank you.
Right. Good afternoon. My name is BJ Johnson, CEO at ClearFlame Engines. ClearFlame is focused on the challenge posed by diesel engines, which remain critical to global economies, moving 70% of the world's goods, but unfortunately are still coupled to the dirty emissions of diesel fuel. This leads to aftertreatment systems that can add $15,000 to the price of an engine, while non-compliance with emissions rules has cost companies like Volkswagen and Navistar billions of dollars. These emissions challenges are forcing manufacturers to consider lower performance alternatives to diesel in order to meet emissions regulations, such as electric vehicles with their reduced range and heavy batteries, or natural gas with their expensive and complicated refueling infrastructure. Fortunately, ClearFlame is offering a simpler solution by taking the diesel fuel out of the diesel engine and instead replacing it with low-cost, clean-burning alternatives. This allows us to maintain the performance of the diesel engine and even increase power by 30%, but while drastically simplifying aftertreatment and lowering fuel costs. Our solution provides similar economic benefits to compressed natural gas, which is the leading diesel alternative, but without requiring high upfront cost or loss of efficiency. My co-founder Julie and I initially developed this technology in the Edwards Lab at Stanford, a GSEP-funded project, thank you. And we're working to commercialize it in partnership with Argonne National Lab outside of Chicago, where we have access to nearly $1 million in non-dilutive grant funding. We're focused on deploying initial pilot demonstrations in 2 initial US markets with good access to low-cost ethanol, municipal fleets, which are often mandated to move away from diesel use, and Midwest farms, where farmers want to use a fuel that they help to produce. We plan to reach these initial customers by providing aftermarket retrofits before eventually licensing our technology to an established manufacturer and finally expanding into other sectors currently dominated by diesel engines, such as marine or stationary power generation. Thank you very much. Again, my name is BJ with ClearFlame Engines, and I look forward to answering your questions at the Expo. Thanks.
Hi, everybody. I'm Aaron Antono from Citrine Informatics, and I'd like to tell you a story about the chess grandmaster Garry Kasparov. So in 1997, Kasparov faced off against the supercomputer Deep Blue in a chess match and lost. In the aftermath of his defeat, Kasparov became convinced that computation could change the way that the game of chess was played. He went on to found a new style of chess called advanced chess, or centaur chess, where a human chess player plays with the aid of a computer. And in tournaments which have invited any combination of human and machine to enter, these centaur chess teams have regularly emerged victorious. So this partnership between human and machine is Citrine's vision for material science, where computational power and artificial intelligence can be driven by expert scientists to drive materials innovation forward. At Citrine, we've worked with partners in academia and industry to apply these methods in fields ranging from structural alloys to solar and battery materials. In case studies with commercial partners, Citrine's tools have been used to decrease development time in R&D projects by more than half and demonstrate 5-fold reductions in testing requirements. We've also collaborated with academic partners to apply data-driven tools and methodologies to their research, including recent publication in Nature on applying data-driven methods to work on 3D printing of high-strength aluminum alloys. So at Citrine, our goal is to give scientists and researchers access to these cutting-edge materials informatics technologies, regardless of their computational expertise, allowing them to leverage the scientific community's data resources, along with their intuition and their expertise to drive materials innovation forward. So if you want to find out more, come visit us at the Expo. Thank you very much.
Good afternoon. My name is Richard Wang. I'm the co-founder and CEO at Cuberg, where we're building the next generation of batteries with greatly improved energy density and safety. This comes out of my graduate work at Stanford, where I was supported heavily by both GSEP and Tomcat. So happy to tell you about what we're doing. I think you know the problem with batteries is lithium-ion simply doesn't store enough energy and certainly is not safe enough anymore for many of the next generation applications we're thinking about. Cuberg is building a new battery technology that delivers 80% more energy density than the best lithium-ion batteries in the world. And we do this using an ultra-lightweight lithium metal anode and a high-voltage energy-dense cathode material. And we do all of this in a safe manner by integrating it with a new electrolyte that we're developing that's thermally stable, non-flammable, and extremely safe, and ultimately allows us to actually harness the energy of these materials without introducing any safety issues or stability issues. We've actually designed this technology from day one to also be a drop-in replacement on lithium-ion production lines. And that's a critical piece of the puzzle because it ultimately allows us to actually reach markets much faster and pursue a much more lean operating model. So I presented on the stage at GCEP last year where it was pretty much still a concept. So today I'm excited to tell you guys that we've really executed on that vision. We've actually proven out this technology in commercial format, cylindrical, and pouch cell prototypes. This is a flashlight that's powered by sorry to blind you, but this is a flashlight that's powered by Cuberg's batteries. So we actually have real things working. We are testing these actively with customers, have a multi-million-dollar deal coming down the pipeline with an oil and gas customer, as well as a lot of traction in defense, aerospace, and medical device industries right now. So please come and talk to us to learn how we can integrate your technology into your next generation battery application. Thank you.
Hi, my name is Rito. I'm the CEO and founder of Indrio Technologies. We make advanced laser-based sensors for chemical detection, and we are poised to disrupt a $32 billion industry of chemical detection. So I have done research on the background of physics that goes into building these sensors for the last 8 years in the mechanical engineering department at Stanford University, and I'm commercializing this in various different applications. My first focus is developing these sensors for natural gas leak detection, and our sensors are our technology, wavelength modulation spectroscopy, is 1,000 times faster, more accurate, and calibration and interference free. And I'm introducing this sensing technology in a portable platform that is able to be deployed in a portable platform like a drone or other devices that can carry it to places which are otherwise inaccessible. And we have done several field trials recently with partners such as Lawrence Berkeley Labs and Schlumberger, and we are gearing up towards more field trials in the future. Please come and talk to me if you would like to know more about us. Thank you.
Good afternoon. My name is Allison Pija, and I'm CTO and co-founder of Mango Materials. We produce biopolymers from waste methane gas that are economically competitive with current petrochemical-based plastics. Our polymers are both bio-based, meaning that they're produced from rapidly renewable resources, and biodegradable, meaning that they can completely degrade at the end of their useful lives. Currently, we're targeting several different applications. One of these is injection molded goods, such as caps or cups, or maybe the case that you put on your cell phone. Another application that we're really excited about that we've just developed is biodegradable polyesters for use in fibers. And these can go into different textiles like apparel or carpeting or other tapestries, or even the bracelet that I have on today, which was made from our polymer. So Mango Materials, the process of producing biopolymers from methane, came out of original research that was done here at Stanford during my and my co-founders' PhDs. Essentially, we produced this biopolymer called polyhydroxyalkanoate, or PHA, which is made by bacteria inside their cell walls. We then use a series of downstream processing steps to separate the biopolymer, isolate it, and purify it so that it's ready for downstream processing applications. And currently, we use naturally occurring methane oxidizing bacteria. Mango Materials, we currently operate a 500-liter pilot plant just up the road in Redwood City at a local wastewater treatment plant there, using their biogas. This plant is capable of producing several pounds of biopolymer per week, and we've done the basic engineering design for our demonstration unit, which will be able to produce thousands of pounds of biopolymer per week. It will also inform the design for our next commercial scale plant, the full-scale commercial plant. For our commercial scale units, we have a decentralized production model where we'll have units at sites of methane production rather than one single large unit. and this will enable us to take advantage of economies of number rather than economies of scale. At Mango Materials, we really believe that a closed-loop bioeconomy is possible, and we believe that methane-based products to replace petrochemical-based products are an important part of this step. Thank you for your attention, and I'd love to show you our samples at our booth today.
Hi, everybody. Good afternoon. So you have to bear with me. I lost my voice last week yelling at my little girl's soccer team. I'm about to tell you about the least sexy Silicon Valley startup company you've ever heard of, so I hope you can bear with me. I was working in the India-Pakistan border area building a solar plant for an engineering company that I helped to found called Ozra. And at this point, natural gas prices dropped in North America and plummeted. And there became a huge mismatch between the price of oil and the price of natural gas. And my co-founder and I became convinced that this mismatch was going to last. And so we sought out opportunities where we could find ways to replace oil with natural gas. Monolith has developed a technology for converting natural gas into carbon black and hydrogen. And carbon black is a $20 billion global market where carbon particles are mixed into plastic and rubber to form composites. The most common example of this are the tires on your car, the hoses at a gas station, the black cables that connect your phone to the receiver. Almost anything you see or touch that is black and plastic or rubber has between 5 and 30% carbon black in it. 99% of the carbon black in the world is produced by burning heavy oil in a very dirty, high emissions process. Our process converts natural gas directly to carbon black with an electric arc and also generates hydrogen as a byproduct. Our products have inherent advantages. It's the purest carbon you can buy. It has huge performance advantages. We also drop CO2 emissions by about 70%, NOx emissions by 90%, and SOx emissions by 99% relative to the existing process. But most importantly, our process requires no federal subsidies, no premium, no greenwashing, extra money from our customers. We produce this at an economically competitive rate that can capture the market based on price alone. We started a demonstration plant in 2014 up at the Port of Redwood City that can produce up to 1,000 tons of carbon black per year. And today we've broken ground on a large 14,000-ton Phase 1 plant in Lincoln, Nebraska. That plant will produce carbon black for users in the Midwest and will also sell hydrogen to a neighboring coal plant that was on the brink of being shut down. That coal plant will stop burning coal and will start burning hydrogen to generate electricity and will become the cleanest fossil fuel plant in North America. We plan to expand that plant and build more plants in North America. Love to talk to you more about Monolith Materials. I do contend it is the least sexy Silicon Valley startup in the area. So thank you.
All right, good afternoon, everyone. My name is Ugwem Maneo, and I'm the co-founder and CEO of Solstice Energy Solutions. We use IoT and software to help connect and manage distributed energy resources in emerging markets and to ultimately enable the shared economy of these resources. My family's from Nigeria, the West African country of nearly 190 million people, and in 50 years will be the third most populous country only to India and China. However, unreliable electricity grids have forced millions of Nigerians to spend over $16 billion annually on backup power supply, primarily in the form of diesel and petrol generators. We believe that in spite of this, distributed energy resources are the future of energy grids in emerging markets. And at Solstice, we're building connected hardware and software technology that will not only manage these distributed energy resources, but create a virtual grid of distributed energy resources in emerging markets. Our first product is Shift. which is a remote energy management platform that allows users in the residential and commercial sector to monitor, manage, and control all power sources. So if you have a hybrid system, that means everything from a simple mobile application, while we're using their data in real time to give them targeted interventions that can help them save money and seamlessly integrate solar and storage if they don't already have it. Right now, when we look at a regional perspective, Sub-Saharan Africa has the fastest growing energy metering and management market in the world for the next decade, growing at a rate of over 234% and presenting a $22 billion opportunity to Solstice. Right now, Solstice is fundraising, but we're also in beta as an early stage company. We have ongoing testing happening here in California, as well as in Lagos, Nigeria. I'm really excited to be back at Stanford, where my co-founder and I got started as graduate students in environmental engineering with the support as well from Tomcat Center. To date, we currently have support and backing from institutions and investors that include Cisco, the US Department of Energy, Powerhouse over in Oakland, as well as recently winning both MIT and Berkeley's Clean Energy Prize and going through the StartX Accelerator. I really look forward to connecting those who are interested in energy and sustainability and emerging markets, and so you can find us in the showcase. Thank you.
I'm last. Lucky you. First of all, thanks to Brian and the Tomcat Center for our early support. My name is Daniel Burrows, and I'm the CEO of a company called Xstream. Trucks generate about 7% of United States carbon emissions, burning about $100 billion of diesel a year. And after this talk, I hope you don't look at them in the same way, whether you want to or not, perhaps. But as you drive home, look at the gap between the cab and the trailer on long-haul trucks. Air flows into this gap, causing turbulence and slowing the trucks down, causing about an additional 5% of fuel drag. What we do at Xstream is we deploy panels out when the truck goes above a certain speed to close that gap, streamlining the truck's aero efficiency, saving that fuel. The amount that we can save is about equivalent to about 20 million tons of CO2 a year, and that's about half the size of Sweden's entire energy carbon generation. The panels deploy automatically and require no trailer modifications. And we've been on the road now for about a year, working in 4 pilots in some of the largest trucking fleets in the United States. But this is really the part one of our company. We consider the panels to be a motivation to install a hyperconnectivity smart hub onto the truck. And what we're doing now is figuring out what we can do with this data source that we have from the truck to deliver other sorts of savings by letting the truck know more about its trailer, about its wheels, about its engine, and putting that data together to perform actionable insights for the truck operators. So that is Xstream. It's the Gap Gorilla, which is the panels, that is sort of a Trojan horse to install this smart hub. And look forward to sharing more about that with you at the symposium afterwards. Thanks for your time.